Okay, so let us look at solving ODEs in this video. How to solve an ordinary differential equation using numerical methods. Okay, the general form of any ordinary differential equation is a d square x by dy square plus b dx by dy plus c x plus d equals 0. This is the general form of any ordinary differential equation. Let's say x is theta and dx by dy is theta dot, d square x by dy square is then theta double dot. Okay, so a theta double dot plus b theta dot plus c theta plus d equals to 0. This is a second order ordinary differential equation. So now let us write convert this into two first order differential equation. This can be done by, let's say, writing q equals to theta and p equals to theta dot. Now these are the two new variables. Now therefore your q dot is equals to p and your p dot is equals to, using this above differential equation, using this equation we will write p dot is equal to theta double dot, which is nothing but minus b theta dot, which is p, plus c theta, which is q, plus d divided by your a. So now we have two first order differential equations in p and q instead of one second order differential equation. Now most numerical solvers will solve equations in this form, and in the case of initial value problems where initial values are given, meaning we know theta at time t equals to 0 and we also know theta dot at time t equals to 0, and we are required to find both theta and theta dot for a certain time range. T is equals to some t min to t max. So we are required to find, the numerical solver is going to find q and p and q, or theta and theta dot, for the whole time. We look at vectors now. So scalars, mass, time, speed, distance, these are all examples of scalars. On the other hand, vectors, we will encounter various vectors in this set of videos where you will have position vectors, velocity vectors, acceleration, angular velocity, so on and so forth, all of these different types of vectors. So now vectors generally have both magnitude and direction. Magnitude and direction, whereas scalars are simply scalars. They have only mass, doesn't have a direction, time, speed, all of these don't have a direction. Whereas in case of position vector, let's say you take a position vector like this, which is going from one point to another point. So the position vector will have a magnitude, which is the distance from this point to this point, and then you have the direction in which it is going. So let's say you have x-axis like that and y-axis like that on the plane. This is your x and this is your y. So your vector v can be written as some x units along I cap, where I cap is a unit vector along x-axis, and then you have y units along j. Again, j is a unit vector along the vertical axis. So x and y are mutually perpendicular unit vectors. So in these videos we will write any vector, so in these videos we will write any vector v as in this form: v1, v2, v3. So this goes till there. Or we can also write it as v1 I cap plus v2 j cap plus v3 k cap, where k cap is unit vector out of the plane of the paper. Or we can also write vector as the magnitude times the direction, where your v is nothing but v1 square plus v2 square plus v3 square, and your direction vector is unit vector along, so it's a unit vector along this your vector. So this is the direction vector. Right. The most commonly known coordinate system is a Cartesian coordinate system, where you have x, y and z axis, right? Where I cap is unit vector along the x-axis, j cap is unit vector along the y-axis, and k cap is a unit vector along the z-axis. So I, j and k forms a unit vector triad. So I cross j equals to k, and this is satisfied j cross I equals to minus k. So I, j and k, if you are I cross j will be k, j cross k will be I, k cross I will be j. So this is how it will go. If you go in the reverse direction, it will be minus. The cross product of two vectors. So let's say a1 I cap plus a2 j cap plus a3 k cap. This is one vector. Cross b1 I cap plus b2 j cap plus b3 k cap. So this is another vector. We're doing a cross product of these vectors. So the resultant will be a2 b3 minus a3 b2 I cap plus a3 b1 minus a1 b3 j cap plus plus a1 b2 minus b1 a2 k cap. Now this can be written as zero minus a3 a2 and a3 0 minus a1, and this will be minus a2 a1 0 times b1 b2 b3. this will be the product of this will give you the I, j and k components. So the cross product can be written in terms of matrices, matrix in the form of matrix multiplication. The cross product can be written in the form of matrix multiplication. So this we will call the tilde matrix, A tilde B vector. So the cross product can be written in this form. So in these videos we will come across cross products of distance r cross f, where you will have, since we are looking at only planar vectors, your r will have only 1 and 2 components, or x and y components, and force will have only also 1 and 2 components. So in these cases where your r has only 1 and 2 components, your matrix cross product written in matrix form will turn out to be 0 0 0 0 a2 minus a1 and minus a2 and a1, and here again 0, and you will have in this form b1 b2 0. So this will end up being just the third row multiplied by b1 and b2. We will also have cases where we will have omega cross r, where we are computing the velocities or accelerations. In this case, your omega will be simply theta dot times k cap, right? And your r will be rx ry 0, since we are dealing with planar cases. Okay, write this as r minus r cross omega, where you will have only b vector will be simply 0 0, so omega will be 0 0 theta dot. So in these cases we will have simply a2 minus a1 0 and b3. So in this will be the form which we will be using.